Hi, welcome to the short tutorial on dynamic analysis using FrameCE. First, go to Loads menu and then click the Response Spectra button. You have to supply the response spectra by clicking the menu button. You have three options. You can use the response spectra from the code. You can import a response spectra from your file, or you can simulate the response spectra by simulating the ground motion given the magnitude and distance. First, I will show you how to use the code designated design spectra. You have to declare the seismic source type, the soil profile type, and the distance to known seismic source. If you are following the code, so you can easily tell which one of the options you need to use. Then back to main window. Next, declare your load case name, the movement direction, either X or Z axis, the equivalent lateral load, and if you don't know the equivalent lateral load, you just generate by clicking the button and then select the options, OK, and this is based on the code, and then click the green button to generate the lateral load. Now you have to declare the scale factor. Now this scale factor is actually to make sure that your dynamic load is proportional to your equivalent lateral load. So if I type here 95.95, that means that total base shear based on the dynamic load is 95% of the equivalent lateral load. So you also have the option of scaling the dynamic load and the direction of the loads. So after this, click the spectral loads button. In FrameCE will do the calculation. It will tell you the number of modes analyzed and the effective mass participation. Click OK, OK, and then this is now the dynamic loads based on the design spectra from the code. Next, I'm going to demonstrate on how to generate another spectra using a simulated earthquake. So I'll go back to dynamic analysis and then click the menu button, select the simulated earthquake response spectra given magnitude and distance. I will declare the magnitude and the hypocentral distance, and then click the simulation button. What I have now is the simulated earthquake motion and the corresponding response spectra. I will export this response spectra to my project, and now I can use this for my response spectral analysis. So there are no changes in the other parameters. So I will go straight to spectral loads button, and then FrameCE tells me that I have used this load case name already, so I have to designate another load case name and then click the button. Okay. This is now the dynamic loads based on that simulated earthquake. The third option for response spectra is to use simulated ground motion from seismic hazard analysis. So I'll go back to response spectra window, click the menu button, and then select the probabilistic seismic hazard analysis menu. Now this option is really useful for Filipinos designing structures in the Philippines because you can specify the location of your structure. Say for example, if my structure is in Bohol, I will select a city closest to that location, and then from there I can move the cursor to the location of my structure. See here, this is the satellite image of a region in the Philippines, and then move the cursor to my structure location, and then I can zoom in like this. Now, you need to have an internet connection, by the way, because this is from Google Map. So this cursor indicates your location. So once you're happy with the location, then click the FrameCE button, and then FrameCE will generate a seismic hazard, consistent magnitude, and hypocentral distance. And then I have here now the simulated motion and the response spectra. Export the response spectra. Again, there is no changes to other parameters. So I just need to declare a new load case name for this dynamic load. Then click spectral loads button. Okay. And this is now the dynamic loads based on that simulated earthquake from seismic hazard analysis. So I hope you learned something from this video. If you have questions, just post it in the Facebook page of FrameCE, and I'm going to answer all your queries. Thank you and have fun using FrameCE.